Welcome back. Now in this video we're going to be looking at a scenario of collision where the two objects are initially moving in opposite directions, and we'll see what we really need to pay attention to when dealing with problems like this. So we have a marble of 0.015 kilograms moving to the right at this certain speed, and it collides with another marble of a different mass that is moving to the left at this certain speed. After the collision, the smaller marble, the first one, moves to the left at 0.315 meters per second. Assume a frictionless surface, and we'll see why this is important. What is the velocity of the 0.03 kilograms marble after the collision? So, what could really help us in this scenario is to draw a diagram and see what is actually happening in the collision. So, let's say we have M1 marble, the one that has 0.015 kilograms, and it is moving in this direction to the right with 0.225 meters per second. And then we have the second marble that we can call M2, and it has a mass of 0.03 kilograms that is moving to the left. It's moving to the left at 0.18 meters per second. So direction is very, very important. We know that after the collision, the smaller marble will move to the left. So this is the before, and the after scenario would have the smaller marble, as it says. Let me check again. The smaller marble will move to the left, and that's M1, at 0.315 meters per second. Now, what's happening to M2? This is something that the equations will show us. So not only will they show us the speed, so in other words, it will give us the velocity. The equations will give us the velocity, meaning will give us the magnitude, the speed, but also the direction. Now, before you start solving this, you need to assign the positive and negative, and this is something that you can decide for every exercise. But what most people do is that usually they take to the right as the positive direction, and then you show it with this arrow and the plus. So anything that goes to the right, you assume it's positive. So the in the beginning, the M1 is moving to the positive side, and then M2 is moving to the negative side. And after the collision, we have M1 that is bouncing off M2, and it's going to move in the negative direction. And this will play a big role in the calculations of momenta before and after. Now we know that the momentum before needs to be equal to the momentum after. And this is because of the principle of conservation of momentum, and since we have a frictionless surface, which means we have a closed system, momentum will be conserved. So momentum before needs to be equal to momentum after. Momentum of the system before, which means momentum of all the bodies involved in the system, should be equal to the momentum of the system of all the bodies after the system. Now, let's look at what we have before. Before, we have M1 moving at V1, and we have plus M2 times V2. And I say plus because not yet, I haven't introduced yet values, nor have I introduced direction. So V1 and V2 refer to the velocity. Now, after the momentum, after the collision, you're going to have M1 V1 final plus M1 V2 final. Now remember, compared to the previous example that we solved in the previous video, in this case, we don't have the two bodies sticking together, okay? So before and after, we have two separate objects that come with different masses and different velocities. Now, the next step is we're taking into account the direction. So M1 and V1. So M1 is going to be 0.015 times 0.225, and this is positive because M1 is moving in the right direction. But now V2 is moving to the left, and that's negative, so it has a minus 0.18 meters per second. So here, and that's where most of the mistakes happen, this should be a minus. M2 is going to be 0.03 times the velocity, which is now 0.18, is equal to M1 0.015 times the final velocity, but the final velocity is as a size 0.315, but it's in the negative, so this one needs a minus in front of it, and that's very, very important, guys. I want you to really pay attention. Why am I introducing this minus? Because the final velocity of the V1 is in the negative direction. Plus M2, which is, I'm gonna write it now as 0.03 times the V2F. Now, for the V2F, even though we don't know its direction, we don't know in which direction it's going to go, even though you can assume that it's going to go probably in the right direction, you can leave as positive, and then the number at the end will show us the sign of your calculation, will show you also the direction, even if you don't know where the marble will move on. Now, from this point on, you're done with physics. From this point on, anything that physics could do for you in terms of equations, it's done. Now, it's all up to math, because this is an equation. I don't want to say a simple equation. There are many tricks here and many points where we could make a mistake. The only unknown is the V2F. So if you're very careful with your calculations, and please double check my own calculations, because it's really late. I had a very, very long day, so I don't really trust my own calculations at this time of the day. So please bear with me and confirm or correct the calculations that I am doing. So 0.015 times 0.225, that's gonna give us a very small number. You're not gonna get numbers like this in the exams, by the way. This is just the example that I'm using. But you also have calculators, so you don't have to worry about this. Just be careful with what you're typing. So 0.03 times 0.18, and this should be this number. I repeat, please redo the calculations. The next one is going to be 0.015 times 0.315. Yes, with a negative. Let's be very, very careful with this one. Plus this number that is not changing because the V2F is still the unknown. So now you need to isolate the knowns and the unknowns. So let's bring, I'm gonna do it quite slowly. So if you want, you can skip to the last part of the video. Okay, if you think you can do all the calculations carefully and correctly. So this should be, yes, so this one, if I typed everything correctly, oh guys, please let me know in the comments if these are the right calculations. Okay, now what I'm going to do is I'm going to bring this one to the other side, and instead of minus, it will end up with the plus, right? You can either say I'm adding this value on both sides, or you can say, you know that better than me, okay? I'm not gonna teach you math this late on this video. If you have questions on how I did all the math arrangements here, let me know. So now this one should give us, let's see, 0.0. Mr. M, where do you find these weird numbers? I don't even know. That is the answer. So this one should be, and then if you divide with 0.03, 0.03, wait, 0.03075 divide by 0.3, then we get 0.1025 meters per second. Guys, I would double check these numbers if I were you and the calculations. I will do it actually also later or tomorrow and add some comments on the description. I hope the methodology is clear. I hope you get the message of the importance of the directions when it comes to momentum because it is a vector quantity. And if you can do the calculations and let me know if I made a mistake, I would really, really appreciate it. Hope you found this helpful. Have a nice evening. Bye-bye.